In this tutorial, we will learn how to create hexahedral structured meshing for a 2D car model in ICEM CFD. It's a well-structured mesh with inflation layers near the car. Let's start. First, open ICEM CFD from the toolbar. Rename it if you want to. First things first, go to Settings and set the number of cores and memory you want ICEM to access for your project. Go to File, Geometry, open Geometry, browse to wherever your model is, open it. ICEM supports multiple CAD file types. Before anything, create name selections for your boundary conditions. Go to Parts. In this TIN file, boundaries are already named, but for the sake of demonstration, let's create a new one. Right-click on Part and select Create Part. Give an appropriate name. Select the boundary and click Apply. It will appear here. Let's start meshing. The first step is to create a block. Go to Blocking tab and select the first option that says Create Block. Select the 2D planar option. Click Apply. A block has been created that covers the whole fluid domain. You cannot see it as it aligns with the outside edges of domain. Let's look at it. Go to Move Vertex option. Select Fixed E option so that the movements are only in 2D. Here you can see the block that was created. This way, you will better understand the next step. Second step is association. In this step, we tell the software which edges of block are meant for which curves of domain. Select Association option in Blocking tab. Left-click to select the block edge. Middle mouse button to confirm selection. Then left-click again to select the domain curve. Middle mouse button to confirm selection again. Repeat this process for all edges. Left-click to select block edge. Middle mouse button to confirm. Left-click to select domain curve, and then middle mouse button to confirm again. Go to Move Vertex option and try to move the vertices now. It will let you move vertices only along the associated edges. Next, we will cut this block into smaller pieces to wrap it around the model. But first, go to Model Tree and turn on the visibility of points. We will use these points to split blocks. Go to Blocking and select Split Block option that looks like an axe. We want to split the block using the points in model. First, select the edge that you want to split. Now, select the point from where you want to split. Repeating this process, we confine the car in a block. We further split the blocks from discontinuities. If you want to reorient the model, you can press F9 to go into dynamic mode. In this mode, we can only move the model and cannot select any edges by mistake. Pressing F9 again will take us back to selection mode. We can also specify to cut only selected blocks instead of splitting all the blocks. Here, you can see that it only cut the selected block. What we are doing here is cutting the blocks into a shape that can wrap the surface of car. Go to Associations and select the first option of Vertex Association. Associating vertices is easier. Simply select the vertex from left mouse button and then the point. The vertex will move onto the point. Here, you can see how we are wrapping the blocks around the car. We need another split here. This whole blocking process is a repetition of block splitting and association. You split the block. You associate. Repeat until your blocking has completely wrapped the model. Let's straighten some edges. Procedure is same, go to Move Vertices. This time we only want movement in X-axis, so, fix both Y and Z axis. Move the vertex, middle mouse button to confirm. Although we have wrapped the blocks around the car, the software still does not know which edges are meant for which curves. Go to Associations. This time we will associate the edges to corresponding curves of car. Left mouse button for edge selection, middle for confirmation, again left button for curve selection and middle for confirmation. Do this for the whole model. I am continuously going back and forth in dynamic mode to move the model using F9 key. Now we delete the unnecessary blocks in the center. We do not want to create a mesh inside the car, only on the outside. Go to Blocking tab and select Edit Pre-Mesh Parameters. Here we will control element size for each edge. Ensure that this copy parameter to all parallel parts is turned on. Select the edge and give it number of nodes. It will automatically give the same number of nodes to its parallel edges that are associated with it. Click on Pre-Mesh. Now we will examine the mesh and improve it wherever needed. This edge needs more nodes. Much better. Give sizing to the fluid domain as well. Let's create a no grid around the car for better mesh control near the surface. Remember the central blocks that we deleted earlier? Well, the blocks were not deleted permanently. They just became dormant and moved to a placeholder called VORFN so that if we need them later on, they are available. And we need them now. Turn on this part. The dormant blocks have reappeared from their death. We will use these blocks to create a no grid around them. Are you getting confused because of the clutter of blocks? Let's learn a new feature that will help you simplify the screen. Right-click on blocking and select index control. These IJ and K limits can be used to hide unnecessary blocks and help us focus only where needed. Don't worry, we just hid them, not delete them. Go to blocking. Split block. Select second option of OGrid. Select all the blocks inside the car. Select the Around Blocks option. Click Apply. An OGrid has been generated around the car. Reset the index control and hide the dormant parts again. Give sizing to the OGrid. You can also control the distribution of nodes to create biasing. There are several methods available. With the default by geometric mesh law, you can specify the size of first element and growth ratio. It will calculate the size of last element. The selected values are appearing besides the given values. You can use these values as reference to give appropriate sizing. You can select any other method. The linear method is my favorite. You can drag these points to create any type of sizing. We also want all other edges to have the same biasing. Click on this linked bunching. Use this edge as reference. It will assign all parallel edges the same node distribution as this reference edge. Now, we have refined mesh near the wall of car which increases towards the outside. Inspect the mesh and see if needs more improvement. Split the fluid domain near the car. This way we can better control the elements near the car. Much better transition ratio. Last element size is too large. Give appropriate sizing. Size variation from 10 to 27 looks good. Much better transition ratio. Repeat the same procedure downstream. Use these already given values as reference for sizing. Inspect the mesh. We have some problem here. Elements are too skewed. Move the nodes to improve mesh quality. Much better now. You can turn off block edges and geometry curves to have a better look at the mesh. Now we will export the mesh. Go to Output Mesh tab. Select the solver. Specify the boundary conditions at each named selection. Save the project. This will create the final mesh using the pre-mesh. Click on Write Input. Open the UNS file. It's a 2D mesh. Specify the location where you want to save the mesh file. Click on Done. MSH file that can be imported directly into Fluent has been created. Let's test it. Open a Fluent system. Import the mesh file in Meshing. Open Fluent. The mesh was successfully translated to Fluent. The boundary conditions have already been set as we specified them in ICEM before exporting mesh. That's it for now. If you have questions or suggestions, please feel free to leave them in the comments. Thank you for watching.